Chapter 5, problem number 50. The moon orbits the Earth at a distance of 3.85 times 10 to the 8th meters. Assume that this distance is between the centers of the Earth and the moon, and that the mass of the Earth is 5.98 times 10 to the 24th kilograms. Find the period for the moon's motion around the Earth. Express the answer in days and compare it to the length of a month. Okay, so 3.85 times 10 to the 8th is the center-to-center distance between the Earth and the moon. The Earth has a mass of 5.98 times 10 to the 24th. And they want us to find the period for the moon's motion and then compare that to the length of a month in days. Okay, so find the period of the moon's motion around the Earth. Okay, so let's say that represents the moon. This represents the Earth. We know R. Mass of the Earth we know. And we know the period of the moon. But we're looking for the period of the moon. So the moon is in circular motion around the Earth. So the centripetal force is provided by the force of gravity. M represents the mass of the moon. ME represents the mass of the Earth. You multiply that by the universal gravitation constant divided by r squared. Now the force of gravity can also be expressed as mass times the acceleration due to gravity out here. Okay, that would be due to the Earth. So it's the acceleration at which the moon is falling to the Earth. So we have the mass of the moon times g. Where g is v squared over r, where v is the speed of the moon. Now you notice that the mass of the moon appears on each side of the equal sign, so that gets canceled out. V we can express as 2 pi r over the period. So I'm going to substitute that in here, and we get 4 pi squared r over the period squared. Solving for period squared, I get that, let's see, I'm going to first multiply r squared on both sides, so I get 4 pi squared r cubed over the period squared. And now I'm going to multiply both sides by period squared. And now I'm going to solve for period. So I get the period is equal to the square root of 4 pi squared r cubed all over GME. Okay, so let's do the numbers. Okay, so this is going to give me the period in seconds. So 3.85 times 10 to the 8th. We have to cube that. And I'm getting a huge number for seconds. And now I know that there's 3,600 seconds in an hour. So I'm going to divide this huge number by 3,600 seconds to get hours. And there's 24 hours in a day. So I'm getting 27.5 days. Which which agrees nicely with the number of days it takes the moon to go around the Earth.